Hello everyone, my name is Gerard Moroney and I'm a project manager at IOHK and I'm here to talk to you today about smart contracts. Okay, there's me, Gerard. I'm a mechanical engineer by background and I did research into fluid mechanics before I moved into technology. I've been working in technology for around 20 years now, and I've been at IOHK for almost a year. And I'm responsible for the smart contracts work that we're doing. So what are we going to talk about today? Well, today I'm going to do a brief introduction to smart contracts. I think you're probably all very well versed in what smart contracts are, so I'll keep it fairly brief. But I think it's important we all have a common understanding before I go and describe the challenges and what IOHK are doing. We'll then talk about, as I say, we're going to talk about how they're used, we're going to talk about the challenges, and IOHK's solution. So what are they? So I think very simply, smart contracts, they execute predefined actions when conditions are met. Smart contracts, they provide a language that allows ledger states to be modified. I mean, in essence, what you talk about with smart contracts, you're talking about enforcing certain legal conditions in terms of a traditional contract. And fundamentally, smart contracts are about the exchange of value. You can view a wallet and the tokens that you exchange as a manual form of the same thing, and smart contracts will enforce those movements of value when certain conditions are met. So very simply, here's what a smart contract looks like. You've got the two parties, or you can have multiple parties actually, engaging in a smart contract, which results in a transaction that is stored in the ledger. And the magic, as I say, all happens at the top part in what's in the smart contract, and that's what we're going to talk about today. So it's got a high predicted growth potential, smart contracts. You've probably all heard about all the wonderful things that smart contracts can do. I think it is very, very capable, and there are many things that we can do. And it's all about kind of exploring where the right and wrong parts for that may well be. The enterprise market is also growing, and there's been a lot of interest there. And there's, blockchain as a service platforms out there now that are providing out-of-the-box smart contract solutions for things like supply chain management. So there's an awful lot of things happening, a lot of things are being tried out. And like with any technology, any new technology that you start to use, there'll be things that work very well, things will be okay, and things maybe where it's not that suitable. So we're in a very kind of exciting time right now in terms of what smart contracts can and can't do, and finding that out and learning and experimenting and so on. So smart contracts is really good for lots of things. One of the things that's very interesting is the whole area of KYC, or Know Your Customer. And that's all about verifying certain pieces of information about individuals and organizations to make sure that you've got the due diligence done so you do the right thing. In a lot of companies, a lot of organizations, there's a regular process where you have to go through what's called KYC to make sure that the information you have about organizations, individuals are correct so you can transact, especially financially. And that can be quite a tedious and repetitive task, but it's very important. And there's been a lot of discussion and research about how smart contracts can enable that and make it better. And because smart contracts, they implement some of the features that you know in the blockchain, like immutability and being distributed, there's a lot of advantages there as well. Being distributed means that essentially you can't stop them from being executed once they've been put in place. And the immutability means that nobody can change the records after it's been completed. So there's a lot of options there to get great amounts of trust by executing something in the form of a smart contract. So when do you use them? So okay, I think I've talked about it already, but just to summarize it. So if you want to deal directly, when you guys came here, you might have talked to a travel agent who booked your ticket, or You might have talked to a car hire company that gave you the car. I mean, imagine if you could talk directly to the airline or to the people who have the vehicles. To eliminate an intermediary is a really important thing. Real estate is one really good example where you might want to do that. Realtors, they perform valuable jobs, but realtors and lawyers, a lot of the work that they do could be eliminated using smart contracts. So dealing directly is a very important advantage of smart contracts. And record keeping as well, like I mentioned before. One of the advantages of smart contracts is its association with the blockchain and the fact it's immutable. And having this very detailed record, which is highly assured, highly trustworthy, that you can depend on, is a big advantage. So anything where that confidence is required in what you do is a very important thing. And then there's the increasing and the decreasing part. So what smart contracts allows you to do is to increase the reliability of the transaction, because it's enforced, because it's not something where humans are involved in making sure that certain criteria are followed or not, regardless of how complex. You've got a much greater amount of reliability that's going to do what it's intended to do. And trust is also a big plus, because now you've got more confidence that things will behave the way that they will, that you'll get your money when you perform a certain service, that's another plus. And then the things that are reduced are fraud. I mean, I think as I've mentioned, once you've got something in the form of a smart contract, the likelihood of somebody doing something bad or not fulfilling their contract or whatever it might be is less. So fraud is reduced. And then the costs are lower as well, because you're not using as many people to perform the different actions. And these actions can be trivial at the start, but when you're looking at very detailed financial contracts, for example, there can be a lot of people who need to be involved to sign things off, to check things, and being able to use smart contracts for that work, especially financial contracts, is a big saving in terms of cost. So a practical example would be the crowdfunding. So crowdfunding, as you know, is where people put in money for a certain project, and when a threshold is met, then the investors can use it. And there's been a lot of work done on using smart contracts for crowdfunding. So with a smart contract, what you could do is you could go through all those steps of getting funds, and if the criteria was met, then the funding would be released to the person who's asking for it, and if not, it would automatically go back to each of the contributors. And that's really powerful, and that can be done without people or anybody being involved. So there's a big benefit to using smart contracts for things like that. So the challenges, well, smart contracts, as I said, they have lots of possible uses, but one of the big challenges about smart contracts relates to security. So a lot of you are aware of the different security problems we've had with Solidity on Ethereum, the DAO hack, and other ones like that. And these things are not trivial, and especially when there's large amounts of money involved in the transactions. So that's a big challenge with smart contracts, is how do you improve the security of the language and the platform which it runs on. So, like coding mistakes and poor coding have led to losses of millions and millions of dollars. And there have been lots of reports about poor validation of smart contracts. The checking hasn't been correct. I think for a lot of you here who are developers, you're probably familiar with the fact that it's possible to test various parts of the program, but to test every single combination is very, very difficult, especially when you have large numbers of conditions and variables that you need to test with. But that still doesn't mean that you have to say, well, that's too bad. When there's millions of dollars involved, it becomes something that you just can't not do. And then there's been studies of smart contracts that are out there that I think it was 3.4% were vulnerable to manipulation. And they did this by checking lots of smart contracts against known issues. So these weren't new problems. There were existing problems that were out there. And there was a very high, well, 3.4% may seem small, but when there's lots of money involved, it can be quite significant. And what these things do is, even if it's as low as 1%, it it affects people's confidence in the technology and their desire to use it to transact, especially when there's things of value involved. So, other challenges with smart contracts, and these aren't really with smart contracts per se, but they're related because, and they have to be considered, because if you don't think about these challenges, then smart contracts won't realize their true potential. These are things like scalability. So, if more and more people decide they want to use smart contracts, how are you going to be able to support that in your platform? That's a very important consideration. Interoperability between different smart contracts and different platforms is an important thing, as well, as if you want to get more and more acceptance and more utility for what you're offering. The limitations and flaws in existing languages I already mentioned. I think sometimes as well, when we create technology, it's very easy to get lost in the moment and to create something that's really, really cool without necessarily thinking, how does this work for finance, or how does this work for supply chain, or how does this work for logistics or manufacturing? So they don't always consider the business vertical's needs. And then the final part is it's not fun. I'm a software developer in my past life, and I try and do a little bit now, but I have to say that Solidity would not be something I would want to sit down and code in. I find it a bit difficult. It's just not as enjoyable as other languages. So, getting on to what are we doing as a company, what are IOHK doing? So, first things first, IOHK, we are a Hong Kong-based organization, and we developed the Cardano platform upon which the ADA cryptocurrency sits. So our platform allows you to, exchange ADA via wallets, and we've also been, looking at the smart contracting capability that's in the market right now on other platforms, trying to understand what it is that's good about it, what's bad about it, and how we can provide a very compelling offering to our community so that they can make best use of smart contracts on the Cardano platform. So we recognize the importance of it for cryptocurrency and business domains. And we think we've developed a solution that addresses the limitations that I've described earlier on, and can also allow us to adapt to changing technology landscapes and business demands as time goes by. One of the exciting things about working in the blockchain space is that things are definitely changing very, very fast. And you need to, when you create a solution, be mindful of its extensibility. So I've done this right now, but I know 6 months down the line, maybe this vertical could be looking for these kind of features, or there might be these legal changes in this jurisdiction that I need to be mindful of. So we think we've got a solution out that we're going to be launching in the very near future that's going to accommodate both of those considerations. And we're also mindful of experience. So it's all well and good to create wonderful technology, and we are all about creating pretty amazing technology, but we want to make sure that the people who are using it, the end users of smart contracts who will be using for different things, the developers of smart contracts who will be creating these applications to use them, things like exchanges, people who operate the nodes in our cluster, whatever those might be, we need to think about them. And that's one very big part of what IOHK does, is to think about the people who will be using the technology and how it's going to work for them, and to make sure that they've got a very good experience, that the technology is easy enough for them to use to provide beneficial solutions to their customers, and that it's enjoyable. So, you've been talking for a while, Gerard. What are you going to do about it? Well, what we're going to do about it is Project Goguen, which is the first part of our journey to provide smart contracts capability. So, the Project Goguen, as I say, has a number of different elements, which I'm going to go into next. I'm going to talk about the virtual machines that we're introducing to run smart contracts. how we're going to address the scalability challenge, and how we're going to consider the end user and the developer in what we do. So the project delivers smart contracts capability for Cardano in what's called the CL, or the computational layer. Cardano right now exists purely as what we call a settlement layer. So if you have a wallet and some tokens, you can exchange them between you. So we're building a new layer on top of this called the computational layer. And the computational layer will allow smart contracts to be executed. And you're probably asking the question, why are you building a different layer? Well, the reason we're building a different layer is because of the scalability concerns for one point. We need to create something that will be extensible as time goes by. So we are expecting that there'll be lots of people who want to run smart contracts on Cardano. And while you could run them on our settlement layer, we recognize that a new layer is better because that layer can be expanded over time to deal with the demand. And there are various other reasons as well, but that's one of them. So as part of that project, we're doing a lot of different things. We're doing some very, very fundamental research. So we are a research and an engineering and a customer experience and an education company. We have a research laboratory in the University of Edinburgh under Professor Aigelas Kayas, and his team are working on research regarding things like sidechains, which allow different blockchains to communicate with each other, and a number of other things regarding consensus. So sidechains is a big part of this project. It's to allow the different the settlement layer and the computational layer to talk to each other. We have what's called chimeric ledgers, and chimeric ledgers are our solution for being able to support both UTXO and account-based transactions on one single platform. Cardano is UTXO based, but a lot of the smart contracts that are out there are account based. So for example, Solidity. So as part of our solution, we're going to be able to support both. You'll be able to run your Solidity contract just as easily as you would be able to run a UTXO style contract on our platform. And multi-currency. So right now Cardano supports the ADA token, but with multi-currency you'll be able to create your own ERC20-like tokens to use on the platform. For virtual machines, we are going to be providing a number of virtual machines. There's Yeli and KVM, which I'll talk about later, and then there's Plutus, Plutus Core, which is a UTXO-based virtual machine. And then we're also thinking about the users. So in everything that we do, we always take time to think, how does this affect the developer and what's good for them, and how does it affect the user? So we spend a lot of time and money running events all over the world, and I think we've run a few in Korea in the past, where we talk to the community and get their feedback. So one of the outcomes from this, one thing I'm hoping from each of you here, is that you'll take time to look at some of our test nets and some of our environments and give us your feedback and tell us what is good about it for you and where you'd like us to improve it. Because that's really at the heart of our strategy, is getting that feedback from the community. So that was the overview, and the project itself has a number of different work streams or sub-projects essentially. So I'll just go through them very, very briefly, and then I'll dive into what we've actually done and the architecture, so on and so forth. So sidechains, like I've mentioned to you before, is our technology for being able to communicate between the settlement layer and the computational layer. The chimeric ledger allows us to support UTXO and account-based transactions. We've got multi-assets then that will allow you to create your own different types of tokens and trade them on the platform. We've got Plutus, which is it's a general purpose language for writing smart contracts, the UTXO style. Marlow is a DSL, or domain-specific language, designed for financial contracts that sits on top of Plutus. KVM and Yeli, then these are virtual machines that run account-style transactions, in the case of the KVM, and Yeli, which also runs account style, but it's a more universal. I'll go into that briefly. And then, of course, end users and external developers are also big parts of our consideration. So I'll talk a bit now about the design. I think I've mentioned to you already, we have the settlement layer and we have the computational layer. So how does that all work? Well, the settlement layer is just, it's one single blockchain, one single layer, which uses UTXO style accounting. And it's got a very basic, it's got a basic structure in terms of the types of actions that you can perform on there. The whole idea is we want to provide some computation, but very limited computational capability on the settlement layer, and most of the advanced computation will be on the computational layer. And then what we have is, I say, one settlement layer and multiple blockchains, which form the computational layer, and they're connected via the side chains. And on the computational layer on the different blockchains, you can either have UTXO or account-based style transactions. And you can run as many of these blockchains on the computational layer as you want. So you can, theoretically, create a blockchain for a certain type of application or business vertical or organization or consortium to perform certain activities. So it's very, very scalable and very adaptable to changing business needs. So here's a picture. Hope it makes sense. So this kind of reiterates what I just said before. The single settlement layer, and then the computational layer made up of multiple blockchains with the different types of virtual machines that you see here. Plutus Core, the KVM, and Yeli. And I'm going to go into a little bit more detail about that later on, but the important thing to remember is one blockchain, settlement layer, multiple blockchains, computational layer, connected via side chains with different virtual machines running on each of the blockchains in the computational layer. So the virtual machines. So the virtual machines that we're going to be launching as part of this project, there's KVM, which essentially is the Ethereum virtual machine, but created using what are called formal semantics. So for any of you who use Ethereum and Solidity, you'll be able to run your Solidity smart contract on the KVM without making any code change. So it's a way for you to gain an introduction to our platform and how it works using code that you've already written and you're familiar with without making any other change. So it's also a way for you to kind of get some confidence and assurance that how we're building things is correct. Then you have Yeli, which is another virtual machine, and it supports, it's an account-based virtual machine as well. It's a register-based machine, which has some differences, and it supports some of the Solidity smart contracts that you're used to running, but it has some restrictions. I mentioned to you earlier on about the, I think it's 3 or 4% worth of smart contracts that people found out in the wild, essentially, that have flaws with them. Well, Yeli has, one of the features of Yeli is it doesn't allow certain known issues to be executed in smart contracts. So if you try to run a piece of code with the DAO hack on it, for example, it would fail. So Yeli, at one level, what it does, it provides you the ability to run Solidity, but in a more assured way, because it has a lot of protections in there to prevent bad activity. But Yeli also has other capabilities that would allow you, in the fullness of time, to run smart contracts in any language, whether it's Java or JavaScript or Python. And that's part of the strategy for Yeli, and I'll talk about that a bit more later on. So another part of our design, which we are focused on delivering, is coordination. So smart contracts, if you look at the way that they They have to be able to run for full utility. There'll be parts of the contract that would need to run on a blockchain and parts that would need to run off-chain on things like wallets. So we're creating a design that will allow, where necessary, off-chain and on-chain execution of different parts of the smart contracts. And then within the blockchain itself, there would be certain parts of the contract that will need to run on the main chain, on the settlement layer, and parts of the smart contract will need to run on the side chain, in the computational layer. So as part of our solution, we're considering all of those things for the maximum amount of flexibility and utility. And that, obviously, is where coordination comes in. That's a very important thing. And it's also part of our solution. So let's take a little bit of a deeper dive into the account-based machines. There's the KVM and there's Yelly. So I think, as I mentioned, there's been a lot of flaws discovered with existing smart contracts in Solidity that have resulted in many, many millions of dollars being lost as a result of sometimes poor, but sometimes poor programming, sometimes flaws in the language itself. So to be able to make sure that everything is safe and can be run with a high degree of confidence that things will do what they are supposed to do and not what they won't, we need to be able to design things in a very, very rigorous way, using formal methods and with the ability to perform verification of the smart contracts after they are created. So this is the approach which KVM and Yelly is based on, or it's one of the approaches. So in order to do a formally verified virtual machine, you need to have a language framework. And a language framework needs a number of properties, which are described up here. And one of the offerings to create this ideal language framework, which could then be formally verified when you create the virtual machine, was done by Grigory Rosu from Illinois University. And the framework he developed was called the K framework. So this project, its ultimate goal is to deliver Yelly, the Yelly virtual machine for our computational layer, and allow users to define smart contracts in high-level languages. So the whole purpose of, as I say, of this is to create a virtual machine which is formally verified using formal semantics, and to be able to provide the tools that you need to be able to verify the smart contracts themselves before execution, you can have high degree of confidence that they'll do what they're supposed to do. So what we have done is we've delivered the K EVM, which is the semantics of the Ethereum virtual machine in K. And like I mentioned, you can run your Solidity contracts just like in the EVM. You can actually access the code. All of the code that for the modules and the components we're talking about here are freely available on GitHub. So anybody can go and see those, and the links to those will be following at the end of this talk for those of you who are interested in it. So the KVM is actually completed, and it's now available on the IOHK, on an IOHK testnet. So you're more than welcome to go away and try it out. We have a command line interface which allows you to interact with the virtual machine and run your own smart contracts. We have a faucet so you can get tokens, and we're working on building a web-based IDE so you can actually write Solidity through a browser and have it sent directly to the virtual machine as well. So it's there right now, it's there for you to use, and I would ask each and every one of you who are interested in this to go there and to try it out. And in order to make it easier for you as well, we've provided a help section where you can learn about, a basic smart contract, the syntax of it, and you can just take that information and run it on the platform yourself and just get an experience for it. So then we've got Yelly. So Yelly is, as I say, another virtual machine also based in the K framework. It's register based, so it provides better performance, and results in more accurate gas predictions and lower gas consumption for contracts. It's designed using formal methods and semantics. You can run your solidity stuff just like on the EVM, except if it's got these known flaws, in which case the smart contract will be rejected. It's also available on a testnet, so the link is there, and I would encourage you again to try it out. And we've got a number of translators which we're building as well. And the first one is for Plutus, which is one of the languages I'm going to describe in a minute. So what it does is you can write, we're creating a translator where you can still write your code in Plutus, and then it'll be translated down and run on the LE virtual machine. And we're looking at different techniques to provide other translators. So this is a very exciting thing, because what it means now is, in theory, you will be able to run use many different languages to create your smart contracts, and they would all employ the same gas model in terms of gas consumption, which is quite significant and quite interesting, because it does provide you with a way of comparing things directly using the different languages, because you're using the same virtual machine and the same gas model. So as part of this work stream, we're still working on a number of other things. We're looking at plugins for Yeli and additional training materials. When you launch testnets, you launch them for various reasons. First of all, for the community to provide you with feedback on bugs. But one of the interesting occurrences for us has been people actually want to program in Yeli. Now, Yeli is it's like a machine code type language, and it's programmable, and people do it, but we didn't think there would be a lot of interest. But some interest has been expressed, so we're creating plugins for Yeli, and we're going to be also looking at additional training materials for people to be able to program directly in Yeli itself. We're working on something called semantics-based compilation. That sounds very complicated, and it is. So with semantics-based compilation, you define the formal semantics of a language, and once you've done that, using various techniques, you can write translators to translate from one language to the other. So the advantage to this is it's entirely essentially done by machine. Once you've defined the formal semantics in one place, the translator is created by a machine, and you can then have JavaScript translating down to Yeli or whatever language you might want. And that gives you great benefits in terms of errors, in terms of scaling it out to accommodate different types of languages and environments. And it just opens up the ability for us to allow people with any language out there to write smart contracts and have them run on a machine with very high performance capabilities and a universal gas model across all languages. We're looking at performance improvements and surface languages. So surface languages is really just what languages are we going to use for the semantics-based compilation. Performance improvement is looking at the virtual machine itself and saying, okay, it's so fast right now, well, how are we going to progressively make it faster? Because our approach throughout the project has been extensibility and looking far ahead into the future. So while the performance of the LA virtual machine may be okay now for certain circumstances, we know that over time, as smart contract utility grows, there's going to be more of a need for higher performance on the LA virtual machine, so we're thinking about that now. And then finally, we're looking at expanded tools for provability. And what is that? Well, that's essentially tools to allow you to verify the properties of the smart contracts. So security, as you can see, is something we're considering. It's a big theme through everything that we do. And the provability is another thing, to show that a smart contract will do what it's supposed to do and won't do what it shouldn't. So Plutus. So Plutus is our smart contracting language for decentralized applications. So the Yeli and the KVM are virtual machines upon which you can run Solidity or Plutus and hopefully many other languages. Plutus is a language, and it's also there's a virtual machine. So I'm using the word it kind of interchangeably here. So convenience for app developers means it's a full stack language. It can do both the off-chain part, the things that occur outside the blockchain, and the on-chain part in one function. It's got superior safety and security, and I'll talk a bit more about that shortly. And obviously it integrates with Cardano's UTXO ledger. So safety and security, well, it uses functional programming. So for those of you who are not familiar with it, languages like Haskell, which I'm going to talk about, use functional programming, where everything is referred to in the form of functions. And that provides what's called a very clean semantics. So if something can be described in a very small amount of code or a small amount of theoretical definitions, then it's generally easier to verify that it's going to do what it's supposed to do and won't do what it shouldn't. And that's what provides the safety and the security that I'm referring to. And then Plutus Core, which is the virtual machine, is the foundation for code safety and security. Full stack, well, I'm going to talk about something called template Haskell, which is the way to perform the off-chain and on-chain parts of the smart contracts in one place. And integration with Cardano. So you're probably all familiar with Bitcoin and with Ethereum. So Bitcoin has a very, very basic scripting language, but Ethereum's Solidity is far more advanced. So what we're looking at is bringing that advanced scripting language to UTXO-style transactions, of which there isn't many in the market right now. I think we're probably one of the first to actually do this, to provide that capability. But we're going to provide it in a way that's going to allow you to create smart contracts for both the off-chain and on-chain component in one place, and to do it in a near human readable way using Haskell. So just to kind of go into full stack, just to talk a little bit more about that. When you create a smart contract, the bit on the right, which you see here, is the Solidity part. But people, when they talk about smart contract creation, they kind of forget about the other part, which is usually like JavaScript or something similar. That you need both of those together to be able to make use of your smart contract. So there's quite a lot of code there. So the off-chain part is what we call coordination, and the off-chain we call transaction. So it's a two-level or two-stage programming. So our solution for that is to do the off-chain part in Haskell and to do the on-chain part in Plutus TX. So I mentioned about this being all part of one thing. So we're going to provide something called template Haskell, which is a combination of Haskell and Plutus TX that will allow you to define the coordination and the transactions in one place. And an example. So this is an example of how a crowdfunding application could be written using template Haskell. And you can see above that here's the Haskell part, and here's the Plutus TX part. And these combine together to form the template Haskell, which will define both, as I said, the coordination activity and the transaction parts. And in looking at it here, the syntax of this is fairly straightforward. Considering you're talking about a crowdfunding application, there's not a huge amount of code there. And it's pretty readable in terms of what's happening at the transaction part down below and the coordination activities that happen above. And as I say, the ultimate goal for this is to provide UTXO smart contracting capability like you have for account-based, and in a relatively straightforward way, using a quite readable and easily understandable instruction set. But ultimately, what we also want to do is take it to a point where non-developers can create smart contracts. So not everybody here is maybe a full-stack developer or is interested in all these things. So we need to be mindful of, to create greater accessibility for smart contracts, consider non-developers as well, and how they can do it. So we're thinking about using Marlow to be able to perform that activity. I'll come on to Marlow next. So Marlow is a DSL, or domain-specific language. It's kind of the interface between Plutus Core, Yelly and KVM, and the real world. So real world has time, it has states, it has lots of different things like that. And Marlow provides the ability to be able to interface with the real world via things like oracles and other types of data sources, and execute smart contracts using Plutus Core and Yelly. It's Haskell-based, and it's designed specifically for financial contracts. So it's a special purpose DSL, domain-specific language, for financial contracts. It uses principles of observations and questions, which I'll go into in the next few slides. And what we're going to be delivering from out of the Marlow workstream is a domain-specific language for the blockchain and tools to support it. So we're mindful whenever we do these things, not just to give people a reference document and say, here's how you code in this language. We're also mindful of tools to make it easier for you to develop things, and training materials so that you understand how to perform certain activities, where you can learn more things, so on and so forth. So like I said, Marlow is focused very much on interacting with the outside world. So the outside world has, there's real-time and random events that it needs to consider to be able to perform certain activities. And there's also commits or commitments that you need to make as well. So if I'm performing a contract with somebody else and there's money involved, it needs to be possible for me to commit some money and that person to commit some money, and that money to be held until the natural duration of the contract. And that's another aspect of Marlow that's different, is its consideration of commitments. I think there were problems with earlier Solidity contracts where there was no time-based limitations, which resulted in funds being locked up or contracts never being able to complete properly. So one thing that Marlow is very clear about is making sure that there are explicit time-based limitations on all aspects of it, so that the contract can never be held up by one individual or another. So the Marlow language, here's an example of how it looks. So it's very, very simple, even though the picture might make it seem a little bit more complicated. It takes inputs, states, and contracts and some observations, and outputs a state, a new version of the contract, and a set of actions that have to be done. Here's an example of the language, Marlow. So as you can see, it's pretty readable. For the activity that's being proposed here. So what happens, you've got to wait a certain amount of time for certain things to happen. There's choices that need to be made, and there's actions if people don't commit something in time, and there's other actions if the commitments take place in the prescribed manner. Then we have Meadow. So Meadow is the implementation for Marlow. It's an IDE for visualizing and for creating of Marlow DSL smart contracts. Additionally, as part of what we do, we're considering, as I say, language and IDE plugins for Plutus, Yelly, Marlow, so on and so forth. And we're also looking at libraries and APIs for developers. So latest status, a lot of the research has been done on the sidechains, numeric ledgers, and multi-assets. Plutus, we finished coding. Marlow, we're looking at formalization in COC, which allows for greater verification of our smart contracts. KVM and Yelly, those virtual machines are completed, and we're looking at improvements now, performance, end user and external developers, integration. We have 2 testnets done. I'm here in South Korea to see you all. And want to know more? Here's some details. Especially thanks to the team from UPBit, including Victoria, Jack, Ju Yin, Park, and everybody else. And one last thing. Gansa hapnida.